Hello, my name is Uma Rajagopalan, and today's video is about using the momentum principle to generate a model of a collision between two monster drink cans. The object of this lab was to choose our own adventure and create a model of anything of our choosing and demonstrate it on VPython. For my adventure, I chose to demonstrate the momentum principle between two objects as they collide into each other. The momentum principle describes that the momentum before and after the collision are the same. That is, the sum of the mass times the initial velocity of each object is equal to the sum of the mass times the final velocity of each object. In addition, the momentum is also equal to the force times the change in time. There are three types of collisions: elastic, inelastic, and maximally inelastic collisions. An elastic collision is unlikely to be seen because it requires that the change in kinetic energy is zero and that the object bounces back after the collision with the same velocity at which it started with. Considering that there are other forces acting on the object, this is highly unlikely. An inelastic collision is one where the objects don't bounce off each other, and a maximally inelastic collision is one that has the maximum energy dissipation and the change in kinetic energy does not equal to zero. These are the equations used throughout the analysis. In this model, some initial conditions were given. The mass of each object was 0.439 kilograms. The initial velocity of the first can was 0.582 meters per second in the negative y direction, and the initial velocity of the second can was 0 meters per second since it started at rest. Using the given information and the formulas, the force of the first can on the second can when they collided was determined to be 0.124 newtons in the negative y direction. This in turn caused the velocity of the second can to increase and the first can's velocity to decrease. The first can's velocity decreased to 0.124 meters per second in the negative y direction, and the second can's velocity therefore increased to 0.458 meters per second. This shows that the principle of conservation of momentum was preserved. To determine the force of the first can on the second can, the total momentum was set to equal to the force times the change in time. In solving this equation, the force of the can was determined. A video of the model in VPython can be shown as seen above. Because friction was not included in the net force calculation on the object, both the objects had greater speeds than they would with friction. This is also why both of the cans came to a stop a short time after the collision occurred, even though no directly seen force was acting on them.